In a previous podcast, we talked about the difference between potential and potential difference. So I'm going to talk about both those things in the context of ground, specifically defining what we mean by ground in circuits. So let's go back to one of our previous examples where we looked at the difference between potential and potential difference. In that example, we had two resistors. We defined the potential difference between those resistors to be minus 8 volts. We go from A to B. B is 8 volts lower than A, and the change in potential B to C minus 10 volts, or point C is 10 volts below point B. So that's the situation. So applying our polarity, we kind of know the current is going down. And so a potential set of potentials that would satisfy this situation are the potential at A is 20, the potential at B is 12, and the potential at C is 2 volts, right? B is 8 volts lower than A, and C is 10 volts lower than B. Okay, so that's possible. So what happens if we add ground? So now we add ground. Essentially, ground defines the zero of potential. Essentially, we take a wire, we connect it to some point, and we connect the other end of the wire to essentially the earth. And the earth is a big ball of charge, and we can pull as much charge or put as much charge as we need to there. So we can essentially keep the potential between this wire to be whatever is the earth is, and we define that to be zero. We could define it to be anything, but typically we define it to be zero. So in this example, we have the same potential difference between A, B, and C. We connect ground, put point C to ground. Now what does that do? Well, that essentially defines the zero of potential energy. So we know that point C has zero potential energy. We know point B has to be 10 volts higher, so the potential at B must be 10 volts. And the potential at A has to be 8 volts higher than B, so it must be at 18 volts. So it has to be there. There's no other choices that'll satisfy that condition. We connect ground to point B. Right now we've defined this point to be zero. Point B has zero potential. Point A has to be 8 volts higher, so it's going to be a plus 8. We know C has to be 10 volts lower than B, so it's going to be at minus 10 volts. Okay, so this has to be the potential. These are the potential differences. This has to be the potential given that we've connected this point to ground. Okay, so there's ground. So let's look at ground in a circuit. So here we hook a battery up to two resistors. We hook it up and we find the change in potential across the 2 ohm resistance is 4 volts, and the change in potential across the 1 ohm resistor is 2 volts. So this is referred to as floating, right? There's no fixed potential. The potential could be anything, anywhere. But if we come in and we add ground, now we're saying that point has to be zero. There's no other choices. Everything's the same, right? We've just fixed one point. It's sort of like calling the ground zero in mechanics. Doesn't matter. The ball still falls to the ground. In this case, the current still flows through there. We have 2 amps through each of those resistors. That's zero. Well, if that's 4 volts, then we know this point up here has to be 4 volts, and down at the bottom, this potential here is minus 2 volts. So that's fine, right? Because if we go from this side of the battery to the other side, we know we have to have a change of 6. Going from minus 2 volts to 4 volts, the change is 6. So everything is fine. Of course, we could hook the ground up to a different spot, right? We could hook it up down here, and essentially we're saying this is the zero potential. The potential at this part is 0. If we go up between the resistors, we go up 2 volts. That's fine. We go up above the second resistor or the first resistor, then that has to go up 4 volts, so now we're at 6 volts. That's fine. We know the potential change across the battery has to be 6 volts. We go from 0 to 6. That change is 6, so we're happy. So that doesn't affect the circuit. Like hooking up one ground doesn't affect anything. What you have to be careful of is if you hook up 2 grounds in 2 different spots. Now normally this isn't something that you would do on purpose. This is normally something you do on accident when you go to bring in some kind of an oscilloscope or a voltmeter or something that has a fixed ground end. And so if you do this on accident, right, you've defined the zero of potential at both these spots. That means you've defined the potential at each side of this resistor to be 0 volts. That means the change in potential is 0 volts. That means the current through that resistor is going to be 0 amps. so no current's going to flow. What's that mean? Well, that means the change in potential across this 2 ohm resistor has to be 6 volts. So we're going to have a 3 amp current, whereas before we had a 2 amp current. So having these two different grounds definitely changes the entire circuit. So what's going on? Right, here's 0, here's 6. That's good. That's a change in 6. What's happening to the current? The current flows. We get 3 amps through this first 2 ohm resistor. Then it flows to ground. Right, then it flows out of ground and back to this other battery. So we've essentially shorted out this 1 ohm resistor. Right, there's no current going through that resistor. So you just have to be careful. But in general, the only new addition about attaching a ground into the circuit is that that's a 0 of potential energy. That ends this podcast.